So in last session, we were talking about this unit, introduction to machine learning, right? So we have seen some applications of machine learning, training versus testing also we talked about. And we talked about types of learning or types of machine learning, that is supervised, unsupervised, semi-supervised, and reinforcement learning. This is what we have seen till. Okay. Now let's try to talk about these topics, binary and multi-class classification and accessing classification performance and handling multiple classes. So let's try to talk about these things first, and then maybe we will go and we will try to discuss about principal component analysis. Again, see what has happened is before discussing principal component analysis, you should go and you should create a model first, right? So but generally it should happen like this. First of all, we should have this linear models first and then this one. Actually it should be like this, but I don't know why they have mentioned PCA in the first image itself. Maybe I will try to just discuss the concept of PCA, and then I will try to show you implementation of that in Python. Okay, so let's first of all talk about as we discussed about supervised, unsupervised, semi-supervised, and reinforcement learning, let's try to talk about classification, binary and multi-class classification. Now, talking about this binary class classification. So, binary classification is nothing but wherever you have two classes. Right? So, as I told you that whenever we create a model, we divide the data into training and testing. So, in that training and testing data, we have some features. That is, we have some columns, and out of those columns, some columns are going to be input columns, and one column is going to be the output column. And in that output column, if suppose if you want to solve a problem statement, if you want to develop a model in which you want to classify a patient as a patient who is diabetic or whether the patient is non-diabetic. You want to create such a model, right? So that's a problem of classification. Okay, so here in this case there are two classes. So this is a problem of binary class classification. This problem actually comes under binary class classification, where you have two classes. Binary means two, right? So maybe to solve classification problems, yesterday I talked about, or I have given you list of algorithms, like you can make use of logistic regression algorithm, right, to solve the classification problems. Even you can make use of decision tree, you can make use of random forest, you can make use of XGBoost algorithm and new Bayes algorithm and KNN algorithm and so on. There are different algorithms to solve classification problems. So whenever there are two classes, we call it as two class classification or binary classification. Right. Now talking about multi-class classification. For example, if suppose maybe if we get time, or maybe in third unit we will try to develop some models, and in that case if we have a topic called as decision tree, oh yeah, KNN we have, right? K means algorithm we have, maybe KNN okay, this one we have, right? So here we will try to see one classification problem where I have a data set ready actually. So what we need to do is we have some data set, or otherwise let me show you the data set itself. See, talking about this particular point, talking about multi-class classification, let me show you a very simple example. Which type of models can be developed here? So let me go and try to check it here. Let me show you a data set where we can go and we can discuss about multi-class classification problem. So I have the decision tree. Decision tree implementation is there. So here we have got this particular data set, y quality underscore name. Now what we want to do here is, in my case I have already implemented this particular problem statement. Okay. Now check, client is going to give this kind of a data set. It's a CSV file actually, and I think you people are aware about CSV file now. CSV stands for comma separated file, right? We talked about that. Remember that. So there will be questions in your exam also. What is CSV? What is Excel and so on. So we already talked about CSV. CSV stands for comma separated value. Okay. So this is how CSV file is going to look like. Now talking about multi-class classification, I just want to show you a simple example. See, there are different columns: fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, free sulfur dioxide, total sulfur dioxide, density, pH level, sulfates, alcohol, and this last column is going to be quality. So this last column is our target column. It's called as target column, or we call it as output column. And all these other columns, they are called as features or input columns. Okay. Now we want to develop such a model. So from this particular data set, I have actually trained a model. We haven't discussed that actually, how to train it in terms of implementation. We did not discuss that because that is not there in your syllabus. They in first 2 units they didn't ask us to develop a model. So I will have to do syllabus wise actually whatever is mentioned in the syllabus. So see what happens is here we want to create a model, and that model is going to be trained on this data. So I think it is near about 1,500 number of observations or rows in this CSV file. And this data we are going to divide it into training and testing, and then we are going to develop a model. So in this model, this is our target column. So this is a problem of multi-class classification. Why? Because this quality is on the scale of 0 to 10. For example, see this first wine with all these properties, its quality is 5. Second wine 5, third wine 5, fourth wine 6, 5, and so on 7. Someone is having 4, and so on. So how many classes are there? 0 to 10. That means total 11 classes are there. So this is the problem of multi-class classification. Okay. So both the types of problems we can solve with the help of all the algorithms for classification, whatever I have shown you. So here, talking about this particular multi-class classification, this particular point. So that was a data set, sample data set example which I have shown you. That is a problem of multi-class classification. Or even suppose if your target column is passenger class. So passenger class can be first class, second class, third class, right? So there are 3 classes for passenger class. So again, it is more than 2, right? So more than 2 is going to be multi-class classification. So you can go and you can solve multi-class classification also with the help of C. Logistic regression specifically, you will see that is specifically used for binary class classification. Wherever there are 2 classes, right? In the output column or target column. In that case, we make use of this logistic regression, right? That is called as binary class classification problem. Whenever there are 2 classes, but whenever there are more than 2 classes, so it's going to be multi-class classification. So these types of problems, for this type of problems, we make use of other algorithms which can be used for classification other than logistic regression. So, for example, there is a decision tree, there is a random forest, there is a XGBoost, and so on, right? And yes, KNN is the best algorithm many times. So these are the algorithms which can be used for multi-class classification. Now, accessing the performance, classification performance. So what happens is, to access the classification performance, there are some metrics. Suppose, see, when one is going to make use of all these things, accessing the classification performance. So the suppose you created the model, right? Your model is ready. Now you want to access whether how that model has actually performed. How much is the accuracy of that model? How many correct results it is giving? That is called as accessing the classification performance, or accessing the performance of your classification model. So for that, we want to make use of metrics. Which are those metrics? So specifically talking about classification problem, the the metrics which we make use of is, first we should know about something called as confusion matrix. There is something we make use of once the model is developed. We make use of something called as confusion matrix. So what is confusion matrix actually? So confusion matrix is, see, I am talking about this particular point, okay, accessing classification performance. So talking about confusion matrix, it looks like this. Again, it's a separate topic, okay, and it should have been mentioned first in your syllabus, but it is not there in syllabus. That's why I'm just trying to give introduction to you people, right? Because see, in third unit they mentioned those points. Actually, some of these points should have been in the first unit of second unit, right? So anyway, I will just give you introduction. This is one way to access the performance of the classification model. So confusion matrix. Confusion matrix looks like this. So what it is having some values here. So what happens is, Suppose if you have developed a model and that model is helping you to classify a patient as diabetic or non-diabetic patient. Okay, so here, uh, okay, I hope I am audible to everyone. Just a minute, let me share the screen once again. Is it visible, all of you? Can you just confirm? Okay. So see, to understand, to discuss this particular concept, we were talking about accessing classification performance, right? So let's try to discuss this one. I hope everyone is able to see this black screen. So I was talking about this particular confusion matrix. Confusion matrix is one of the metrics or one way to access the performance of your classification model. Now, what is this? In a short, what I can say is it looks like this, something like this. So matrix only, which has certain values. Okay. Suppose like this. Now, suppose you created a classification model. That model is helping you to identify whether the patient is diabetic or non-diabetic. Now, let's suppose uh, you have data of 100 patients. Okay, and this is showing actual, not actual values. Vertical is this particular thing is showing predicted values or prediction. Okay, predicted value by your model. Whatever the prediction by your model, it is showing. And this is showing actual. This row is showing actual value for actual value. So this is diabetic. Okay, diabetic. Actual predicted diabetic, actual diabetic. Predicted non-diabetic, actual non-diabetic. Or maybe you can take it as 0, 1 because machine learning algorithms, the basic requirement is that for all the machine learning algorithms, the data should be in numeric format, right? Now, we want to see what is confusion matrix, which is one of the metrics to access the performance of a model. Okay. So in this case, if this is showing you predicted values, this is showing you actual values, and suppose if you have 100 patients, our model is completed, our model is done, our model is completely trained. Now there is a time to test the model, right? So how to access the performance? So out of 100, suppose now see in confusion matrix, what happens is there are some values. So those values are having some names. Let me first of all tell you what are the names. This is something important. See, this is called as true positive. TP is true positive, and just diagonally opposite to that is called as true negative. This is called as false positive, and just the diagonally opposite to that is called as false negative. Okay, so let me just write it down here. This is nothing but true positive. TP is nothing but true positive. TN is nothing but true negative. Okay, and this FP is nothing but false positive. So if one wants to understand what is confusion matrix, then one needs to be clear with these concepts: false positive, and this Fn is nothing but false negative. Okay, that is the meaning of all these terms. False negative. Now, what are all these things? See, as I said, this is again that is predicted output. This is the prediction by our model, and this is the actual result by the actual result, whatever we have. 0, 1, 0, 1, something like that. Now, what giving the true positive? Now, true positive means if you take this example, diabetic non-diabetic. If your model is saying that, suppose if your model is saying out of 100, if your model is saying 60 people are diabetic, and actually 60 people are diabetic, that is called as true positive. Okay, I will again repeat. Out of 100 people, if your model is able to identify 60 people as diabetic patients, and actually they are diabetic, that is called as true positive. What is true negative? If your model is saying that out of 100 people, 10 people are non-diabetic, and actually they are non-diabetic, That is called as true negative. That means you are talking about negative output, non-diabetic, but that negative output is true. So true negative. Here we are talking about the positive, that is diabetic patient. So this output about positive patient is true. So true positive. Okay. Now what is this false positive? Suppose here if I am writing down 10. Okay. So it means that your model is saying that there are 10 people who are non-diabetic, but actually they are diabetic. I will again repeat. Your model is saying that there are 10 people who are non-diabetic, but actually they are diabetic. That means our model is wrong here. Right? That is false positive. We are saying that they are non-diabetic, okay, but actually they are diabetic. Right? So false positive. Now what is false negative? Suppose false negative is 20. So addition should be this 80. That's why addition 20. Okay, addition should be 100. So you can check it. This addition is 70, this addition is 30, total you should get is 100. Okay? Otherwise you go like this 80, 20, total you should get is 100. Anyway you should get 100 dollars. Right. Now see what is this false negative? So it means that your model is saying that there are 20 people who are diabetic, but actually they are non-diabetic. So here also your model is wrong. Right? That is called as false negative. So we can say that 60 plus 10. So for this 60 plus 10, our model is true. So our model is able to identify 70% of the people correctly out of 100. Or if you want to go and if you want to calculate the accuracy of your model, accuracy is equal to, this is the formula, TP plus FP, sorry, oh yeah, TP plus FP divided by TP plus Tn plus Fp plus Fn. So what is the value of TP in our case? True positive 60. What is the value of Fp in our case? 10. And what is the value of this? 100. So what is the accuracy? 0.7. That is 70% of the accuracy. This is how we access the model with the help of confusion matrix. For many people, confusion matrix is very confusing, right? But I just tried to explain these things in a very simple way, right? I hope you people got the idea what is confusion matrix. As I need to stick to your syllabus, that's why I did not show the implementation, right? So definitely I will show. Yes, wait just a minute. I mean I will answer your question. Okay, sir, 20 should be FP, right? 20 should be false positive. False positive. Okay, yeah, it should be FP because see, FP is equal to false positive. That means our model is saying about positive things. So yeah, you can take it like this. FP and Fn. Okay. So true positive, true negative, false negative, false positive. These are the values. So you can take it as FP. Yes, that's right. False positive. Okay. Now people are asking question. Why aren't we going with true positive? Since we know that it is the most accurate, why others required? So to answer your question, Sharon, why aren't we going with true positive? See, let's take an example. For example, you created a model, you created a classification model by training, right, by with the help of some data, and that model is identifying whether the patient is affected by cancer or not. Okay. Now, in that case, in your confusion matrix, your model is false positive value. The false positive value of your model is 20. That means what? That means your model is saying that there are 20 people who are affected by cancer, but are they affected by cancer actually? No. So if your model is, see, in that kind of a domain, if you are saying someone that okay you are affected by cancer, even if he is not affected by cancer, so in that case it's very critical. That's why we take care about other values. Are you getting my point, Sharan? It depends on the domain. If a person is not affected by some disease and your model is saying that he is affected by that disease, is he not going to die? That's why we take care for FP and FN. Are you getting, Sharan? So anyway, we need to make use of all these things in real time, right? You take, maybe you can go and you can develop a model to identify whether the patient is affected by COVID-19 or not, right? But yes, we will not give importance to these things. Maybe suppose in case of if you are going to develop a model and that model is good for you, okay, whether the person is loyal or not. So in that case, okay, even if you do not care about it, that's okay, right? So that is actually we call them it as, there is something called as precision we find out, and there is something called as recall we find out, and there is something called as F1 score we find out. So it is not like that we are only dependent on accuracy. Because if you are dependent only on accuracy, your model is giving you 90% accuracy. But here your model is identifying 20 patients as cancer patients, even if they are not cancer patients. What is the use of that in that healthcare, in specifically in healthcare domain? Definitely, your model is identifying 90 people correctly. But if it is not, if it is identifying 20 such people who are not actually affected by that particular disease, and even if they are not affected, your model is saying that they are affected. Again, that is not good. In that case, that's why we go with something called as precision, recall, and F1 score. Again, this is not included in your syllabus. Okay, I hope I cleared it out. Right. So, talking about this particular point, whatever is mentioned in your syllabus, that is accessing classification performance, confusion matrix is the answer to that. Right. And confusion matrix, with the help of confusion matrix only, you will be able to get other things, right? So based on confusion matrix only, you can go and you can calculate accuracy. You can go and you can calculate precision. You can calculate recall. So this talks about positives. This talks about negatives. And F1 score is actually harmonic mean between these two. Again, that's a different story. But yes, this is what we make use of whenever we want to access the performance of a classification problem, the model which is created for classification problems. Okay, so just understand the concept of confusion matrix. I hope it's clear to everyone. Now, talking about this particular point, handling multiple classes. Now, what we do is, in case of handling multiple classes for this particular point, so suppose, as I told you, as I gave you example of passenger class, right? So passenger class can be first class, second class, third class. Now there are multiple classes or more than two classes. So if there are two classes, suppose diabetic, non-diabetic, here you can make use of 0 and 1. But if you have more than two classes, you cannot make use of 0 and 2. Because otherwise, what will be the meaning of this? The meaning of this will be that this class is greater than this, or this class is greater than this. So you cannot go and you cannot compare this, right? So if there are more than two classes, so what we do is, in case of handling multiple classes, what we do is, definitely we try to divide that particular class also in numbers, that particular data also in numbers, because the basic requirement of any machine learning algorithm is that the data should be in numerical form. Definitely we try to do that, but we use some methods. Whenever there are more than whenever there are multiple classes in the target column, in the output column, what we do is we divide that particular data also in numbers, but we use some techniques to convert that particular data. So what we do is we use some labeling techniques. Whenever there are multiple columns, so handling multiple values, multiple classes is nothing but what? This is the example, handling multiple classes, right? So even if you go and you can try to do it with the help of this kind of a assignment of numbers, but again that will not give you a good model, I can say. Later on there will be a over-period model, right? Over-period model is what? Over-period model is the model which is going to give good accuracy at the time of training, but it will give less accuracy at the time of testing. And that's why we make use of some labeling techniques. What it does is, what happens in this labeling techniques is, instead of assigning these numbers, so see, there are three classes, right? Passenger class 1, 2, and 3. So what we do is passenger class 1, passenger class 2, and passenger class 3. So for this record, for this observation, if person traveled in this class, this will be 1. Person that if person is traveling with this class, that means obviously person is not going to travel with this class. Since this will be 0. If second person is traveling with this class, so this will be 1, others will be 0, right? If the person is traveling with this class, others will be 0. If the person is traveling with again this class, again others will be 0, right? This is what we do. But we do not maintain 3 columns for all the classes, right? I mean, there is not only one hot encoding we make use of. There are different techniques available. That's why I did not mention the name of it. Otherwise, people will confuse. Because see, I mean, this is not mentioned in your syllabus, right? That's why I did not take a name. Maybe when we will try to discuss, when we will get more time, at that time I will show you different techniques. There is not only one hot encoding, because otherwise what people will say, I mean, people will say that only one hot encoding is the answer for label, because there are a lot of disadvantages with one hot encoding. Are you getting? I mean, that's why I did not mention the name. Those people who are aware about this technique, that's good. But try to understand why I did not mention this particular name, because I did not want you people to limit to only one technique. There are some limitations to one hot encoding. Is it clear? I mean, you are saying one hot encoding. Definitely it can be used, but that is not the only answer. Right? That's why I'm just trying to view over it, because I need to complete this particular thing, and then maybe when we will implement that, at that time we will talk about different methods. But people remember, there is, as Amin is saying, that one-hot encoding is the technique which can be used here. But remember that there is not only a one-hot encoding, there are better methods as compared to one-hot encoding, which can be used to go and to handle multiple classes. Okay, that's why do not limit it to one-hot encoding. So those people who are not aware about it, don't worry, right? Because see, there is internet, there are number of platforms which are available where you can learn this, but try to learn correct. Try to learn correct whatever is required. Because I have seen people really very confused when to use what. There should not be any confusion once you understand all this, right? That's why I'm trying to just teach you all these things. Maybe when we will go to this one, I told you. See, what I will do is, so maybe those people who are aware about it, for them it will be easy. Here I will discuss theory about linear regression. Okay, I will show you some points which can be used in linear regression as well as other algorithms. I will go and I will try to implement linear regression, and I will try to develop a model, how to train the model, how to develop a model. So we will create a mini project kind of a thing. Once that is done, then I will show you how to deploy that particular model on the cloud. In real time, I will show you how to deploy this particular cloud. So in the world, you may be at any location, you will be able to access my model. So again, for deployment, again you people might be aware about AWS, Amazon Web Services. There is something called as Pivotal Cloud. There is something called as Microsoft Azure Cloud. There is something called as Google Cloud Platform. There is something called as Heroku Cloud. There is something called as Oracle Cloud. So there are different options. Right? Out of this, either I will show you on AWS or I will show you on Heroku. So that you people will also be able to do this, and you don't have to pay any money to make use of cloud. You might have heard about cloud, right? Now, for example, WhatsApp is on cloud. As WhatsApp is on cloud, that's why everyone is able to WhatsApp from anywhere in the world, from any location in the world. So that's how I will be showing to you also, right? But I am just trying to go step by step, and I'm not mentioning all those things specifically because I do not want to create any confusion for the people who are not aware about all this. Those people who have already done maybe some courses, something like that, definitely they might be aware about this, right? But in between, if you people are aware about all these things, just let me know. I will skip that part and I will move to the next one, right? But what I feel is many of them, they are new to all these things. That's why I'm trying to discuss all these things from the basic. And again, it is also mentioned in your syllabus. That's the only point. Otherwise, I would have started with models only, maybe mini projects, and I would have showed you the implementation of all the algorithms. That's why I started with a Python, then R, and then I discussed about data types and all those things. And then gradually I'm trying to move the topics. Yeah, people be frank. Okay, if you people are aware about all these things, just let me know. I will just totally skip the topic. I will move to the next one. No problem with that. Okay. So handling multiple class. So what we do in this case is even to people, right? So instead of this using these 3 columns, what we can do is we can make use of any 2 columns. So for example, I will use P1 and I will use only P2. So how are you going to write on this first record? So it will be like 1 0, right? So obviously if any one of these three is one, that means obviously other two are not used. This will be like what? This will be like 0 1, right? Third record will be like what? We will write it on it as 0 0, because if both of them they are 0, that means obviously the passenger class is going to be 2, right? So yes, these are the techniques which we can make use of to handle multiple classes in the target column or output column, right? So those are some of the techniques, definitely, and other techniques are available for us. But yes, as I told you, there are different algorithms which can be used or which can work very well with multi-class classification. Generally, logistic regression is not preferred from multi-class classification because it will not give good accuracy for multi-class classification, right? For binary class classification, logistic regression is yeah, it will give good accuracy, but maybe for multi-class, it might not give good accuracy. Right? Again, they did not mention logistic regression in first two units. That's why I did not discuss. Okay, so these are some of the things which I wanted to talk about here in this second minute. So whatever the videos, whatever I'll be sharing, just refer that. There will be different questions based on this. For example, you know that we have discussed something called as EDA, exploratory data analysis, right? So how it can be used in machine learning or data science. Right? So there will be very simple questions based on the discussion, whatever uh, we have done here, right? Suppose here I told you that okay, linear regression is used for what? Linear regression is used for prediction or creating the predictive model. Suppose here I told you that whenever we want to create the model, right? First of all, what we do is we train the model, and we train the model on which data? We train the model on training data, right? So remember this: we train the model on training data. We test the model on test data, right? And I told you that it can be 30, 70, 30, it can be 80, 20, and so on. Again, it's not a hard and fast, right? And in case of binary class classification, you have two classes. In case of multiple class classification, you have multiple classes. Talking about all the supervised and unsupervised of these things, I have given you examples of supervised learning. Whenever we talk about supervised learning, I told you that the data is labeled in case of supervised learning, right? So that is in case of supervised learning. In case of unsupervised learning, the data is unlabeled or not labeled. Remember all these points regarding this second year, right? So maybe I think in your exam, you might see 15 questions, 15 objective questions, for which you will be having 30 minutes, and these will be based on these two units, unit 1 and unit 2, right? And I even told you that for unit 1 you need to refer whatever I have shared with you, whatever the documents, whatever the tests, whatever the questions I shared with you people, you can go and you can refer. If you people are knowing about all these things, do not refer anything, no problem. So moving to the next one, now talking about principal component analysis. Now here also, what I will prefer is, uh, before going for principal component analysis, there should have been some algorithm they should have actually added into your syllabus in first unit or maybe in second. But again, here I will try to give you an overview about PCA. Now, what is PCA or principal component analysis is? See, uh, what happens is it starts with something called as, or the reason of using principal component analysis, or what is the purpose of principal component analysis. Let's try to discuss that particular. Again, implementation of this is also ready. Okay, and let me tell you, PCA is used for what? PCA generally is not going to give you. Okay, Monisha Kohli is saying that sir, we have studied PCA in maths for AI subject. Okay, then Monisha, can you tell me what do you understand by principal component? What is the meaning of principal component, Monisha? I hope same is with other people also. Monisha, can you tell me what is the meaning of principal component? If you studied this in, so that if you are aware about that, I will not waste your time. Can you just let me know, Monisha? I will just try to unmute you. If it's good, you can unmute yourself, Monisha.
So PCA is usually used to reduce the dimensionality of a data set.
What do you mean by that?
To reduce the data set basically.
So, for example,
Like feature engineering, may we can use just to like.
I have 500 columns in my data set. Okay. So, what PCA is going to do with this data set? Yes, you can unmute yourself, Manisha.
So I can tell you the steps that are involved.
Yeah, either you tell me the steps, either you
So
tell me the steps or
suppose
tell me the purpose of this.
suppose we have two columns x and y. So
Mhm.
we're going to compute the mean of both the columns, and then we'll find out mean subtracted values, then we'll square the values, and then we find an eigenvector matrix,
Mhm.
and then subsequently we'll after getting the eigenvalues, we
Okay.
will multiply the x and y columns to those uh, values, and then we'll write the new values there.
So, why are you doing all these things? What is the last purpose? What is the aim? Why are you doing all these things?
So like I said, I think it is used to
Hmm?
reduce the data.
So, if you are going to reduce the data, are you not going to lose the data? So, is it good to lose the data? Are you getting my question, Manisha? See, at least you try to answer. That's good, no problem. Even if it is wrong, no problem. So, is it not, what we can say, is it okay if you go and lose the data? So people are saying, Amin is saying that disadvantages data loss can happen. No, you can go and you can control that. Reducing dimensionality of a data set. Sharon is saying with minimum loss of information. You go this way. So can you tell me, Monisha, if you are saying that it is going to reduce the data, is it good to reduce the data? You can unmute yourself.
So uh,
Or just tell me the meaning of principal component. What do you understand the principal component?
uh, 1 second, sir. Let me plug in my laptop.
No problem. Or yeah, again, those people who are aware about delete the redundant columns. No. PA56 was it? It's not like that. It reduces dimensionality meaning it converts 2D data to 1D. That's what Saloni is saying. Not like that, Saloni. Principal component. You people can answer. What is principal component actually? It is used to discover important features of large data set. Important features of large data set. So the features which are not important, is it going to drop those features? We won't. Is it like that? If some features are not important, is it going to drop those features? No. Okay. So see, obviously, if you are thinking that it is just going to reduce the number of columns, it's not like that. That's the confusion I just need to remove. Yes, anyone want to answer? What is principal component? Monisha, are you there? Okay, she is not there. No problem. Let me tell you. See, even if you people might have seen this, maybe you might be knowing about the theoretical aspect of that. Just try to understand. Principal component is nothing but linear combination of all the columns. Linear combination of all the features. That's how simply I can define it. Now, what do you mean by this? For example, we have a data set, column 1, column 2, column 3, column 4, and so on, column 500. Now, if you go and if you try to make use of 500 number of columns to train the model, it is going to take a lot of time, right? Instead of that, is it possible to train your model on the same data but with less time? How? See, what principal component analysis is going to do is it is going to find out principal components. Each principal component is what? It's a linear combination of all the columns. So it is going to find out principal component 1. So how it is going to find out? that is going to take care by PCA, principal component analysis. PCA method is going to take care for that. Even I will show the implementation. Right. So PCA is going to take care for that. So principal component one is suppose if it is able to represent 80% of the complete data set. It is able to represent 80% of the complete data set. Right. Only one component. So it is what? It is a linear combination of all the features. Try to understand. Then it is going to find out PC2, principal component 2. Suppose PC2 is able to represent 10% of the complete data set. Right. Variance in the complete data set. Then it is going to find out PC3. PC3 is able to represent suppose 3% of the complete data set, variance in the complete data set. PC4 is able to represent suppose maybe 2% of the variance in the complete data set. Right? Yeah, no problem, Manisha, no problem. So PC1, PC2, PC3, PC4, and so on. Suppose you got 50 components, right? So let's try to see now. No, Manisha, it is not. You are saying that it mostly helps to remove correlated features. No, Manisha, it is not like that. Principal component analysis does not help to remove correlated features. Okay, so it if you want to go and if you want to remove the correlated features, you have something called as variance inflation factor (VIF). Right? If the value of VIF is greater than 5 for a particular column, that means that particular column is correlated with another independent column. That's again a different story. PCA is going to PCA is what? It's a dimensionality reduction technique. Try to understand, but do not go according to the name. Dimensionality reduction technique. Now, see, there are 500 number of features in your data set. If you go and if you try to train the model on the 500 number of features, obviously it is going to take a lot of time. That's why what PCA does is PCA is going to find out linear combination of all the columns, and it is going to come with principal component. So first principal component is going to suppose represent 80% of the variance in the data. Second principal component is 10%. Now just check that. I suppose I am satisfied with 95%. I want 95% of the variance in the data. I am ready to lose 5% of the data. No problem. Okay, losing 5% of data is okay for my model, but still I am able to represent 95% of the complete data set with only how many principal components? With only 4 principal components. So instead of these 500 features, you will be having only 4 principal components. What is going to happen is this is totally going to change the data in representation. Obviously, this will also be numbers, but those numbers are not going to give you any idea. You will not be able to understand anything from these numbers because each principal component is going to be a linear combination of all the features. So 80 plus 10, 90, 90 plus 3, 93, 93 plus 2, 95. So I am still able to represent 95% of the variation in the complete data set. From the complete data set with only 4 components. So instead of using 500 number of features, should I not go with only 4 components? Because it is going to increase the speed, it is going to save my time. That's what principal component analysis is going to do. Obviously, not only 4 components, it can be 20, 30 principal components. Obviously, in real time, it depends on the data set, but I'm just trying to give you an example. But definitely, it will be very much less than 500. So, Prajwal is asking, so does it mean that it helps in avoiding data redundancy? So, see, automatically that it can take care, but still you cannot say that let me tell you, even data redundancy will not be there. Rajwal, there will be no question of data redundancy because what happens is in real time, what we do is before passing your data to PCA, we take care for cleaning the data, and in cleaning, we take care for data redundancy and all those things. That's why there is no question of data redundancy when you talk about PCA. Is it clear, Rajwal? Does it answer your question, Rajwal? Can you just let me know? Yes, Rajwal, Varnikar. Yeah. So that's why there is no question of this. Okay. So principal component analysis is actually a dimensionality reduction technique, but it does not mean that it is going to remove the columns. It's not like that, okay? Because each principal component is a linear combination of all the features. That means each principal component is able to represent whatever every feature is representing. So first principal component is able to represent 80% of what all the features are representing. Second principal component is able to represent 10% of what all the features are representing. So always remember, always it is in decreasing order. It is in decreasing order. First principal component always explains more variance as compared to other principal components, right? So it's a data redundancy technique. That's why it is given like this. Dimension, not data, dimensionality reduction technique, and that is nothing but principal component analysis, PCA. I hope at least you people got a basic idea about it. So why don't we use actual data set instead of taking its PCA? Because Sharan, in real time, I given you example, right? In real time, if in your data set you have a lot of features, 500 number of columns, 600, 700 number of columns. If you go and if you try to train your model on the basis of all those columns, it is going to take huge time, and which is not good. That's why we go with PCA. And that's why I told you that PCA is not going to give a classification model or a regression model. PCA is actually used as a pre-processing technique. Is it clear, Sharan? Does it answer your question? Okay, yeah. So that is the reason. That's why we do not go to original data. Right now, let me show you. As I told you that there is a implementation also ready for PCA. These are my notes for PCA. Again, you will get these notes into your video recording. See, this is the reason why we use PCA. The curse of dimensionality. If you want to understand the mathematics behind that thing, all those things are actually explained in detail in my notes. Everything is given here. The mathematics behind PCA. If you are interested, definitely we can refer this. Everything is shown. Even Python implementation also I have shown. And whatever Munish has said, even those steps are also implemented here. Okay. But even if you are not aware about those steps, no problem. You will be able to implement principal component analysis. This is how it is going to happen. PCA. This is what this particular thing is doing is actually it is showing you dimensions, right? How many dimensions are actually needed to represent 30% of data, 40% of data, and so on. Don't worry about this right now. This is the implementation which is shown here for PCA. Now let me talk about this one, curse of dimensionality. Now what is this? See here, if you can check, if you have only one dimension, then that is okay, right? So you might be knowing, right? So you might be knowing different distance formulas. How to find out the distance between 2 points in a plane. If these are the 2 points, how to find out the distance between these 2 points in a plane? You might have studied this in math. If this is point P1, if this is point P2. Now we know point P1 is represented like x1, y1 because it's a two-dimensional data, x-axis and y-axis, and this is x2 and y2. Now, how to find out the distance between 2 points in a plane? So the formula is like this: under root of x2 minus x1 whole square plus y2 minus y1 whole square. This is how we find out the distance between 2 points in a plane, right? That is in case of two-dimensional data, right? In case of one-dimensional, it will be x1 minus x2, as simple as that, right? But what if the number of dimensions go on increasing? For three dimensions, x, y, z, then and n dimensions. For n dimensions, a1 minus a2 whole square, b1 minus b2 whole square, c1 minus c2 whole square, and so on, n1 minus a2, n2 whole square. Just think about this. Number of calculations are going to increase a lot, and it is going to take a lot of time to do all those calculations. And that's what we make use of is we make use of principal component analysis. So this is nothing but what? This is the curse of dimensionality. This is the curse of dimensionality, right? Because of dimension, because of number of because of the increase in the number of dimensions, number of calculations is going to increase, and if number of calculations are going to increase, processing time which is required is going to be more, right? So hard or almost impossible to visualize the relationship. Even if you go and you try to visualize that kind of a data, visualization is also going to take a lot of time, right? You people might be knowing that those people who have tried all the hands-ons in case of art with the help of documents which I have shared with you people, right? You people also, those who try to plot the graphs with the data set which I have shared, you will see that it will require a lot of time. Just think about this. If you have a very huge data set, right? In that case, it will take a lot of time, right? If, and obviously, if you have a lot of features, it will take a lot of time. And that's what PCA is going to come into picture. So everything, whatever I talked about, is actually explained here. What is dimensional reduction technique? Why to use dimensional reduction technique? Right? So it reduces the size of the space in which distance are calculated. It reduces degree of freedom and reducing the dimensionality using dimensional reduction technique. Okay. So in short, it is going to fasten the process. And what is principal components? All those things are actually diagrammatically shown here. Maybe when we will have time in maybe next session, I will show you implementation. Okay, but at least I hope you got a basic idea behind dimensional reduction technique. Okay? That is this particular topic. Again, this is also theoretical topic we will try to study. That is the only point which is remaining. Case study, if you want, I will try to show a model. And anyway, we are going to develop models in project. Okay, so any question, anyone? Okay, no problem. I will stop here. Vasif has already sent the number. Yeah, you can send. All people can send numbers and names. I will just stop here.